Thank you.
Hey, good evening, everyone. Hope we all had a great day and we enjoyed our day at work today. Please let us all. Okay, I can see the thumbs up. Let me get reaction if we're all active and ready for tonight's lecture. Wow. So for tonight's lecture, I would like us to make it as practical as possible. Last class we have a lot of people that were unable to do anything. The whole magic TIA portal seems strange to some of us, and I get it. It's a new software, like a new word entirely to some people. And I also saw some people made effort, and which was commendable. I had someone in my DM, I don't know if the person have joined the live now, that was asking about the input that was being shown on his system. I don't know. I'm trying to get the person name. So if you are the one, you can just say it in the chat. So I want to be sure we've closed out that problem, because I responded to the person and then he didn't give me feedback on that. When you called it in OB1, you said you're seeing input. So, okay. Think I've gotten my person already. You're the one, Michael. So, okay. Also, for tonight's lecture, I noticed something during the last class that some terminologies seem new to some people. Stuff like beat, memory word, input, output, byte, and others like that. It seems strange to some people, and it made the whole class look, should I say boring, or just made the whole class strange to some people. I know I was not feeling the energy, because some people were just there, just saying attendance link, attendance link. Most people were not doing the actual work, which for me, I have a philosophy that most times if I'm teaching, I appreciate that if at all 80% or 70% of people I'm teaching should be able to replicate or do what I'm doing. So that's why most time if during my lecture I'll say, if you have any question, don't hesitate to stop me, don't hesitate to ask your question. So what I'll be doing tonight, instead of going straight to TIA Portal, I'll be introducing some of the main terminologies to you, the beat, the byte, and all of that. I'm sorry, I really want to attend to someone asking for the YouTube link on WhatsApp. So I will introduce most of the terminologies to us, the byte, the bit, the memory, a lot of that, so that we'll know when and where to use them. So you don't just see that we're picking bytes, we're picking memories, you don't know why. You don't know, okay, why are they picking memory here? Why are they using this here? So we would all be informed on the decision we'll be making tonight. So after showing us that, I would also take at least 2 to 3. Sammy, calm down for these people now. We want to do scaling. We won't be doing scaling tonight, but definitely scaling is one of the things I would like to teach. And the move block, there are even other method of scaling you can calculate. Instead of using TIA scaling block, there's a way you can calculate it yourself, which make your work seamless. And there are a lot of trick in TIA portal, which I would love to share few of it that I have within my knowledge bracket, and I think if the time permits, I would dive in. So uh I won't be going to TI Portal directly today, so I would be starting with a slide. I'll be starting with a slide, so the slide would be the one to guide us. After introducing all of us to the slide, then I would expect that at least all of us are on the same page. We can now create our projects, create our tag table, because during the last class I showed us how to create a project, how to name your your PLC, how to write simple program, what to write in your OB1, how to call your OB1, and all of that. So let me share my screen and we can kick in and start right away. Before I start, I think it's best I hear from one or two persons. Sorry, because some people don't like wasting their time. Just want to make sure that we're together. Juliet, are you active with us? Let me just get a reaction or just something in the comment.
Yes, I am.
Okay, that's great. So I think we're good to go. So let me share my screen. Hold up. Another place. Hold up, please. Trying to get the right screen. I have a lot of. So can we all see my screen now? Okay. We cannot see the PLC programming and HMI design. Okay. I think. Oh no 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 no! I don't think that's the right one. Sharing. Not that one I'm sharing. Yeah, this is what I want to share. So good. So we'll be starting with this. So we have PLC memory area. How Siemens PLC save memories. We have the process image input, the I0.0, IB.0, that's input, 0.0 input byte, 0.0 input word, 0 dot input word 0, and input double word 0. So we have process image output, which is the output part of a PLC. We have the Q, so output is denoted by Q. We have Q0.0, Q byte 0.0, Q word 0, and Q double word 0. We have memories also. We used a couple of memories in the last class, but I'm sure some people don't understand why and what they are used for. So we have memory bit, memory byte 0, memory word 0, memory double word 0. We have data block. I explained what a data block is, where I was talking about a bank that you are visualizing a data block like a bank where you can store different currency. In this part, we are storing different variable. You can have a byte, a structure, a double word, an integer, just name it. You can have any data type in your data block. Then we have a temporary bit, which is the one I mentioned the last time, that you can find in an FC or an FB. Then moving forward, so we have data type and addressing notation. If you have any question, you can always drop it in the chat. If I'm too fast, also let me know, please. So moving on, we have different data type and addressing notation. How Siemens categorize data. We have the bool. Bool is what? 1 bit, which is it ranges from 0 or 1. We use it in DI, DO state, flag, timer. That's the one we're using in the last class that I used I0.0. We have the byte. Byte is what? 8 bit. 0 to the range is from 0 to 255. It's used for input or output byte access. So it's denoted by, you can check it here, B. You see what? IB. So anytime you see B, that's input bytes. Then we also have the word. Word is what? 16 bits. So the 16 bit means from 0 to, is occupying from 0 to 65,535. That's the what? Data range. Then analog raw, it takes analog value. We have discrete data and analog kind of data, which is DI and AI. So if you are getting inputs from an analog device, the input does not come as 0 or 1. It comes in analog format. It come in form of waves. You don't get a discrete one pulse shot like 0 or 1. It come in sinusoidal waves, like it goes up or down, 0, 1, 2. So the data is interchanging. So we have analog raw or status word. So these are the kind of data you get from a pressure transmitter, a an encoder. So it's the PLC. After doing your, like someone mentioned, scaling, then you do scaling for you to be able to use it in an engineering value way. So moving on, let's go to the next one. We have integers. Integers 16 bits. So we have from minus 32,768 to plus 32,768. It also taking analog value and small counter. This one allow you to write from numbers like I from number 1, 2, 3. It allow you taking numbers 0, 1, 5, 4. It allow you write number. Bit will not take a number. Bit and byte just take, and bool just take just send signal 0, 1. But integer allow you put numbers and all of that. Then we have double integers, which is what 32 bits. It has plus or minus 2.1 billion. That's the range of data. It's used for large counters and positions, like in encoder, you get feedback. Then we have reals. Reals allow you, that's 32 bit also. The same with double integer. So it allows floating point like 0.01, 0.02. That's why you have 3.4 times 10 raised to the power 38 scaled engineering unit. So once you scale your analog input value, you get it in real format. I think if time permit, I'll be able to show you all of that. We have double word also. So double word where you can get up to 0 to 4 billion. Yeah, so you can get up to 4 billion and 32-bit IOs, large data, very large data. That's what you can store there. We have Siemens I addressing notation. We have I0.0. So if you have I0.0, it means input byte 0 bit 0. So that's the first address on a DI card, the first address on a DI card. We have so if I'm addressing a DI card, you remember we said a byte have what? 8 bits. So you are not counting from 1 to 8, you are counting from 0 to 7. That's why I say I0.7 means input by 0 bit 7. So it stopped there, the 8 DI. So that's already the number 8. It's counting 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's not, instead of 1, 2, 3, 4, 5, 6, 7, 8. So it's counting from 0. That's how you get the 8 DI card. 8 position on the DI card. And we have Q 4.0. That's output byte 4 bit 0. So the output of the of the PLC you are using, the DI card or DO card, of the DO card that you are using, the output part, you are using Q4.0. So is output byte 4 bit 0. That's the part you are using. You are using byte 4 under byte 4 bit 0. Then we have memory 10.3. These are the typical kind of addressing you see us do whenever we're writing program. We say M10, M10.0, which means bits memory by 10 bit 3. So under memory by 10, then bit 3, we have input byte 0. That's input by 0 is covering everything that is in I0 from I0.0 to I0.7. Everything that is there is covering it. So that's 8-bit value. We also have input word 0. So input word 0 is covering 16 bits. So anything that is in from 8 IB0 to what? IB1 is covering everything that is there for the two of them. So that's input word 0. So then we have the input double word 0. That's 32 bits. That's word 2 word. Then we have memory double word 20, which is memory. Okay, this is memory, and we have the data block DBX5, this is a typical data block addressing. DBX5, DB5 under DBS 2.3. I'll show you how to read this also. Then moving on, we did how to create our program tree in the last class. We open your project tree, click on program block. We did that. Then we go to click on main OB1. That's your default programming language, which I showed us how to select in the last class. So to change OB1 programming language, right click on the OB1, select property. That's if you want to change the programming language you're using in OB1. You right click and you select property and then you change it. So writing your PLC programming language, we have number one, programming block interface, which is this upper part. I hope you can all see my cursor. So this upper part is your what? Program block interface. The upper part, then the second section is the program workspace. This is where the actual program is being written. This is where you write your instruction, the start, stop, normally open, normally close. So you can change your program language from the property. So in an FC or a DB, you can have multiple programming language. You can use multiple programming language to write inside. It's not constricted. It's not restricted to one programming language. It's not like you open one FC, you cannot use another programming language in that FC. So we also have what else? The number four is instruction plane. So from the last slide, if you notice, this was where I picked my timer in the instruction plane. So the instruction plane is where you can pick timer, the scaling block this engineer was talking about, you can pick it here. The you can do P and ID control. There are some standard block from CIA that you can just make use of for control, move, function, comparison. You can just pick them here, drag and drop. So some of us will notice during the last class, we're using symbols like this, normally open. Normally open contact, just like your switch in place of your contactor. Let's visualize it like you have a contactor now. We have the normally open contact of a contactor. We all know the way it look like. You have a straight line, then a slant one bending towards your left, then coming down straight towards. So it look like the the slant one is opening. Then once it closes, it turns to normally close. But for TIA portal or PLC programming generally, the normally open is like this, and this is what our normally close look like. It is true when associate bit is 1. So whenever the bits become 1, let's say we associate it with I0.0. When I0.0 receive a signal 24 volts, either from a push button, from a sensor, whenever it receives a signal, then this becomes true. It becomes normally closed. Then it is false when associate bit is equals to 0. So whenever the bit is equals to 0, it goes back on, becomes false. Then for this one, the normally close, when associate bit is equals to 0, it is off. That's when it is true. So whenever the signal has not come in, just like your contactor normally close also. So whenever the signal has not come in, that there's no signal or 24 volts to the A1 or A2, what happened to your normally close? It remain energized. So the same thing happened here. Your normally close for the PLC, for the TIA portal also. Whenever you've not received signal, let's say you associate this with a with a signal I0.1. So whenever there's no signal from the physical address from the HMI, I say from the HMI, from the PLC, then it will remain true. But once, sorry, who is, okay. But once there is a signal, it becomes false. We mostly use this for emergency button, stop push button, like I did in the last class also. We have output coil. This is where you get your signal. So in place of what's this guy called? The normal conventional coil that we make use of, that the output coil, you just wire it, you get a wire and put it at the other end of the contactor. So the output coil for this is always looking like this. This is the symbol for output coil. So once it is true, once all of these conditions, maybe the normally open becomes normally closed, or the normally closed does not receive signal, then it sets the output coil to 1. That means there's signal in the output coil. So we can use for the use start push button, run permissive, sensor active state, interlock condition that must be satisfied. Like okay, the emergency button must be pressed or a door must be locked. In some plants, if all doors to access the machine is not locked, the machine must not start for safety reason. So we can make use of normally open in that situation. So whenever the door is closed, the limit switch sends a signal to the PLC that okay, the door is closed and 24 volts trigger this normally open, it becomes normally closed. Then use the emergency stop push button, fault light signal, normally close interlock that block output when condition is active. So for the output coil, we use it in physical output, internal memory, internal flag, non-retentive logic. The bits directly mirror the run state, so we can use it to latch and all of that. Okay, for this part of it, we say the number one, I think, okay, select the instruction need from the instruction plane. So the instruction plane, you have your normally open, normally close, not the coil, the negation of the coil, everything in your. Let me see if I can open the TIA portal and then show us this. Oh, okay, let's continue like this first. Then this is our normally open, these are normally closed, and this is the coil output for the signal. So you can just drag and drop and put it on it. So we have also set reset. We'll make use of this tonight. So set reset, instead of lashing or try to retain the signal one way or the other, you can make use of set. What set does is retain true even after the run condition goes false. That means if you give it a start command, like from a push button to start, the start command, the output remain on. It remain true even after the input have gone off. So a typical example where you can make use of this is like for the motor control we're doing in the last class of star delta. When you press the start push button, instead of this save you cost of trying to latch and all of that, once you press the start push button, it sets the bit, and once the bit is set, it needs a reset for that same bit before it can go off. So then you need a corresponding reset to that same bit before it will go off. Then this is it, set, reset. Let me zoom in so we cannot see this. So this is a normally open contact, a normally closed contact, then a set. This is a set. So then a normally open, then a reset. So it's just like we can also use it for start stop. So once you press the start push button, it sets the command. Then once you press the stop push button, it resets the command. So once this reset is energized, this goes off. Let me zoom into this part so we cannot see this is the normally open contact. You can drag and drop it. The normally close, not the relay coil output, negation, negating the output, reset, set bit field, reset bit field. We have set reset, reset set, we have scan operation. So we have a lot of logic operation you can make use of right here. Okay, so let's move on. I want us to work on this slide first before. So let's go to comparison. The comparison instruction, we have like if A is true and B, if A is equals to B, then an output should, an instruction should take place. So we use comparison. Let's say we want to say, okay, if this number is, if the number you're expecting from the PLC is 1, uh, it should trigger an alarm. If the number you're getting from the PLC is true, it should trigger an alarm. So this comparison is for comparing two integers. So you are comparing, okay, if this is true, not only integers, real value, if this is equals to this or if this is greater than this, trigger an alarm, trigger an output, we are using to set a coil. So we also have greater than or equals to, we have greater than, or if it is not equal, we have this, if A is not equals to B, so false when set condition is false, when set condition is true. So this becomes true when the set condition is true. The condition means when value A is not equals to value B. Let's say value A is 1 and value B is 2 or 5. So it sets this, the output become true. Then when it is greater than, when the set condition is true when value A is greater than value B. So in place of us having 5 as our value A and 10 as our value B, so what happens is set the output. So then for the less than on, so if value A is less than value B, just normal English. So programming has been made super easy and the user interface is super permissive, like enjoyable. So we also have the other comparison instruction. We have greater than or equals to, less than or equals to, greater than. So if it is greater than or in range, less than out of range. So we have some move and jump condition. So this move condition is when you have a value somewhere, you want to move the value from this place to maybe a dB, copy the value in source in to destination out. So you can copy a value from a position and then you take it to another position. Let me see. I think we have time. We'll be able to enter the TIA portal interface and do some stuff. So we'll be able to use the move command. You move figures from value A, you are moving this figure to another place, value B. Then we have the jump label. If this condition is true, jump to this place. If it's not true, then go downward. We use this copy HMI set point to control variable. So it can be an input from the HMI where we say, allow the operator to be able to give your set point. If the operator set the set point as 0.1, you'll be able to move it directly to a data block for your own usage. Then we have initialize variable on first scan. We set a variable on 0. So I think this is clear. So if anybody have any question, let us ask in the chat now before we open TIA portal and dive in. If you have any slide that is confusing or anything, let me just go back there. Let's talk about it and get it all clear. You want me to scroll back and then you go through it again yourself? Okay, I have Elijah. Oh, by 9 o'clock, I want us to enter TIA. So Isaiah, you can talk now.
All right. Good evening, everyone.
Yeah, good evening,
So,
please.
so my question is, the set and reset, is it the same thing as flip-flops on TIA portal?
Okay, I think I get where you're coming from. Oh, flip-flop is different from set reset.
Oh, okay. Okay.
Yeah,
All right. Thank you.
you're welcome. So is there any other question? Please, if you have question, you can drop it in the chat or just raise your hand. I think we're good. So we'll not have anybody. Hold on, I think I have some question in the chat. Okay. So on set reset, with latching and unlatching, we have it here even in TIA portal. So in place of latching and unlatching, to save yourself the stress of creating another line and then another line of program, then using the output coil to latch the output state. Instead of doing that, that's why set reset is there for you. We make use of the set reset, you see how it operates. What the set reset does is whenever you get a one-shot signal from the input part, what it does is the one shot signal, it hold on to it until there is a signal from the reset side. Once the reset receive a signal, it goes off. So someone said, please come again on what you just said about limit switch. So what I said about limit switch was I said in place of a machine, I think I was explaining, hold on, trying to get what I was explaining. Let me scroll down. Hold on, please. Okay, I was explaining the use of where we can also use normally open command. I said in place of some machine, let's say filler, or I don't know if some people have heard of filler. Okay, don't let us use filler. Let me use a typical example we have in our house. We all have freezers. If you notice a freezer, if you open the freezer door, the light comes on. Once you close the freezer door, the light goes off. What is making that possible is a limit switch. You have a limit switch inside the freezer. What the limit switch does is close to the door. I don't know if anybody have noticed it. So once the door closes against the limit switch, it sends a signal, then the light goes off. It's open the contact and close the contact. So what I was saying about limit switch was that in some industries, we have some machines that, but because of safety precaution or safety condition, the machine door needs to be locked before the machine can start operating. So what programmers and automation engineer now did or come together to do is you add a limit switch to the door of the machine, or you add a PLC key lock, key in pocket, or RFID card, just to make sure that the whole door is locked. So the limit switch on is that once the limit switch senses that the door is locked, then afterward it can now proceed to allow the machine to start. But if the limit switch notices that the door is not locked, no matter how the operator press start button or something, it will not respond. The door will not come up. The door will not open. I think that should answer your question, Michael. Okay. So do we have any other question before we dive into CIA? Juliet, are you still with us, and is everything clear? If I start calling people out.
Yes.
Okay, wonderful. That makes sense.
I'm actually typing a question, so
Okay, I think I would be waiting for it.
okay.
Yeah. So any other person that have a question should also drop their question. I cannot call everybody. Oh, Damilola is not here. Who again? Daniel, you are here. Okay. Just few people that I can remember their name. That's just what I'm trying to make it somewhere. Okay, is it Desmond? It's Diamond, not Damilola. Diamond, you're the one I'm looking for. I think she's here. So cool.
Yes.
Yes. You're the one I'm looking for. Okay. So you are good also. No question from your end, right?
No.
Okay. Okay. Sorry, just I need 1 minute. It's 8:50. 8:50. Okay. So someone made mention of safety precautions. How do we factor in safety measure while designing a PLC? Okay. Uh, from my own point of view, for every machine, there are some ISO, basic ISO standard that safeguard the design of every machine, most machine. So there are some machine that normal ISO standard states that the whole machine should be locked. There should be a safety distance of 10 meters from the operator to the machine when in operation. So for that, there will be a door, and definitely for the door, you want to consider the lock option, the safety door lock option. And the safety precaution is peculiar to different machines. So we might have situation where you have a machine that need intervention of human. during operation. You can't say because of you want to create safety precaution, you lock them out. So every machine has its own, how will I put, peculiarity. Uh, the safety precaution that you would have in a crate conveyor will not be the same as that in a filler machine. So a filler machine, I don't think it needs intervention of human that much when in operation. But for some unpacker might need some, to some extent, might need some human intervention, maybe bottle is bent, this and that. You can't say you lock the whole place that, okay, this person should be out, then you just be having shut down all the time, breakdown that, okay, you have to access it and all of that. So for myself, I always look at it, okay, what are the safety precautions we can put in and the kind of location you are designing for. If you are designing for a place where you know the operators are always prone to bypassing, trying to touch this, trying to touch that, I think you have to consider high safety precautions there. And one thing to have in mind as a PLC programmer or automation engineer generally is that if you are designing a system, it should be as convenient as possible. You are not designing only because of you want it's fine or you want to suit yourself. You are designing and putting the operators in mind. You are putting the engineers that will be taking carrying out maintenance. You are putting them in mind that okay, what and what would make this process easier for them. Because if they say the machine is not okay, the companies or the partner you're working with will also say the machine is not okay. So someone said, please come again with the comparator. So for the comparators, we talked about, hold on, please. Okay. So we said we have equal to, so if let's say A is equals to B, then trigger and output, that's if 1 is equals to 1, trigger and output, not equals to, then trigger and output. That means if the figure you're getting from maybe an HMI is not equals to that of this trigger and output. Okay, Caleb, I'm coming, please. We have less than or greater than also. You know what that means? So we have greater than or equals to, less than or equals to, greater than, and less than. So if this is less than this, let's say value A is less than value B, then trigger and output. If value A is greater than value B. So we mostly use this in, I don't know if, oh, I don't want to be using terms of, okay, let's say you have a scenario where let's say you have two tanks at home. I want to use something practical. You have two tanks at home, and then you want to switch between pumps where you want this pump to start first instead of using floating switch and all of that. You want this pump to start here, and you want this other pump to start when this gets to this level. So you can use a comparator that okay, if this level is higher than this level, or if this level is equal to this level, stop the pump. If this level is higher than this level, these are simple operations that you can put in place. So let's say we have the move block and the jump block. I'll make sure we make use of the move block tonight. So let me hear from Caleb. Then we'll take Collins before we go to Harry Potter.
Yeah, good evening, Mr.
Yeah, good
Lamileka.
evening, engineer.
Good evening, okay. Okay. The question is about the data type. It's about the zoom, byte, words, and like. How about char? I think I said something like that. Kind
About
of
what's
very
that?
new. Char.
About
CHAR.
CHAR.
Yeah.
Uh, in my years of working with TIA, I've not used that data type. I don't know if you are talking about chat or char. We'll go through
Char.
the data type available. There's no that shouldn't be a problem. So what we'll do is because the data type that was listed there is not all. So what I'll do is once you open the TIA interface, we'll go through the whole data
For the
type.
ones you listed are the ones that are commonly used, like that we use
Yes,
in
yes, yes.
throughout
That
the
you
process.
need, yes, most of the time.
If that's the case, let's stick with it then instead of trying to compound.
Okay, char. Okay. I think I get his character. Okay. Yeah, I think I get the one you're talking about now.
Well, since we're
So
not going
let's go
to
to.
just keep.
It's not that you will not use it, but these are the major ones. That was why it was listed here. They are commonly used most times. What you would come and encounter with in different programs and all of that. But I'll show you that one you mentioned also. Yes. Let's hear from Collins before we open our TIA portal.
Yeah, good evening.
Yeah, good evening. Please, let's make it snappy, Collins.
Please, I wanted to be clear of something. You know, this in E-Plan, when we're working on E-Plan, I observed that the normally close button comes before
Yes.
the normally open. Like
Okay.
after the normally close, then you see the normally this. But during on Tuesday, this thing,
Okay.
Tuesday's class, I observed that our normally close open came before the normally close.
Normally close.
Yes,
Okay.
that is the normally close was at the front of the normally open. So why is it down like why is it done like that?
For me personally, for if you are right doing your what's this thing called in E-Plan, you know, if you put your normally open under normally close, do you know it will work? Collins,
You say will it will work? No, I don't think so.
it will not work.
Yeah,
That if you put your normally open first, you now put your normally close in
yes.
E-Plan, it will not work.
No, I mean in no E-Plan, yeah, it won't work now.
It
Even
will
in
work.
real life, it won't work in real life.
That you are putting your normally. That's if you are okay. If you are trying to use it as a stop condition, it will work. Definitely, it will work. Let's do a beautiful example here. I'll open the TIA portal interface. So I'll put in the stop push button in the front, then put the start in the middle, then start it, and then you'll see what happens.
Okay, you put the start at the middle.
I'll put the start in the middle and the stop
Yeah,
one in the front.
but in E-Plan, I don't see whether
Mm.
that one will be able to close the contactor coil if you do it
So
like that.
what happened in E-Plan? The same thing that happens in TIA portal is what will happen in E-Plan. Because if you are putting your normally open first there, whenever you press the switch, what happens? The normally open becomes normally closed.
Yes, that means and when you release your hand, it will off.
The thing will off.
Yes,
In E-Plan, if you put the normally open down, once you press it, it will come out. But if you
yes,
release your hand, will it not go off back?
it will go off.
It will go off. So it's the same thing. In E-Plan, the only thing that will not make it go off is if you latch it also. Like use your normally open contact to latch it. Then it will not go off. It will retain. Or you're using a switch instead of a push button. It will retain. So I will try to do an example for you to make that clear.
Yeah, no
Because for
problem.
me, if you arrange them in different position, it will work. The only what is this thing called to it? The only limitation to it in E-Plan is the lashing sequence. Because if you are doing the lashing and you are putting your normally close first, your normally close will not stop the operation. So let's do a quick one. It's 9 already. Let's enter
Yeah,
CIA
no
portal
problem.
something.
I will too. No problem. Thank you.
Yes, no problem. No, 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 cool. Oh, you didn't join the E-Plan class. Okay. Sorry, I don't know what's going on with my system. Coming. I didn't say patching, no. I said latching, not patching, no. I think this plan, a bit CI Porter has made my system, man. I mean, I don't know. Okay, I think we're back. So let's all confirm that we can see my screen, please. The TIA Portal page. Okay. So I think we're good to go. So in the last class, we talked about how to create a new project. So for tonight, let's create another project. So let's name this one. Let's see. Let me see what name we can give this. So let's give this. Let me see. Let's use what this guy called it, latching. Latching class. What's today's date? 5/. I think we all know how to create projects by now. Don't worry, we'll use the comparator in the program now. So go to project view. So let's add a device. Using a 1500. So remember what I mentioned about the type of PLCs, the compact and modular PLC. So anywhere you see C, is talking about compact. If you can't find the C, that's a modular PLC. What you'll be having is, let me show you an example. Like this, look at this. What you'll be having is just the CPU only. But for this one that has C, you'll be having the CPU and some module. So let's go with this engineer. And okay. Then you set your IP. This is password protection in case you want to ask. Yes. I remembered. What happened the last time won't happen. So this is password protection in case you want to protect your PLC. Is there was possibility for the note available for us to go to from understand? I think I will talk about that. So Moving on, we have if you password protection in case you want to set password for your PLC to prevent access and all of that. But I don't think we need that for this session. So you remove password, you put full access, no protection, then finish. So we'll go to the properties. Under properties, like we did the last time, name, we can call it Ninja PLC. PLC. Then the Profinet interface coming, trying to set our IP address. So let me even change this now to let's use 10. So it does not seem like we're using 192.168.0.1.0, the generic type. So we can use 10, 20, 21 as our IP address. Fortnite, generate this, generate that. So I think we're good then. The IO tag list. Like I made mention in the last class, we have our start. Our stop. So if you notice, what do we have here? We have I10.0. So this is the first address on the DI card, which is what? Input byte 10 dot input by 10 dot bit under bit what? 0. Then we also have input by 10 under bit 1. Then input by 10 for bit 2, bit 3, and so on. Like the way I showed in the addressing of the PLC the other time. So we have input by 10 under bit 0, bit 1, bit 2, bit 3, till look at what is happening now till we get to 7. So I said 1 byte is what? 8 bits. So look at, we have 0, 1, 2, 3, 4, 5, 6. You will not be able to change it to input 10.8. You won't have that. Instead of 10.8, you have what? 11.0. Then 11.2, it continues like that till 11.7. So then we have the output part also. So since we've had the two, let's start with something simple. So this is where you can select, okay, which programming language do you want to use? We have the function block, the STL, and the SCL. So let's go with ladder. So don't complicate things for now. So what name do you want to give it? Testing. Testing block. So this is where we do our testing for search, reset, and many more. So the under instruction, look at these are the instructions available. Let me close this. So these are the bit logic operation, like it was shown in the slide before. We have the normally open, normally close, the not, and the coil for assignment. Then look at this, just drag and drop. Your normally open, can drag it, bring it down here, and drop it. Voila. or you can up here also, you can pick it, drop it down here. Up here, you can pick your normally closed, drop it down here, whichever way you want to make use of it. So I would want us to do set reset first. So we'll see how the set reset operates. So this is the set. This is the set. Look at, I just drag it from this part, bring it down here. Sorry. Control Z. So if you make mistake, undo, you can come down up here, redo, undo. So, or use Control Z. So you put it here, your set command, and then if you want to reset it, you can come under here, put another normally open to give it signal, then your reset would come here. I hope we are still together. Okay. So for this, we have our start command already. Then we also have our stop command. So this is a typical example of the start and stop sequence. Once you press start, this is from input 10.0, which is the first input on the DI card. Once you wire a push button to it, and then the push button is energized, it sends a signal here to the set button. Let's set this to an output Q. Let's go to our PLC tag table. Let's look at our device configuration. Under the device configuration, look at our output address. You have Q4.0, Q4.1, Q4. You can do the address here, or you go to your PLC tag table, show all tags. So you come here. Let's say we want our output to be moto, shift, moto. Enter. Look at what it does. It creates what? An input address. So you're not going to change it by yourself that, okay, no, I don't want this to be an input. Come down here. We have input, Q represents output, and M represents a memory. So we're using an output because it's energizing a coil. Then we have 4. We put 4 dot what? 0. So enter. So we already have our input and our output for a motor. Let's now go back to our testing block. So from our testing block, you just write M. It will show you the list of tags that you have under. And let's say we have more. We have like monitoring, memory. It will show you everything. So you can just click on this motor. So what happens now is, let me click on this motor. So what happens now is, whenever there is a start command, this motor become energized. The motor start running until you press the stop command here. So we'll do this like this, and we'll also use latching method. So before we go for simulation, remember, we will not be able to simulate this with a physical address because the PLC will be expecting you to use a push button, a physical push button. So what I will do is can create an or statement here. Instead of changing this entirely, create an or statement, put a normally open, then close it. So do the same thing down here. Just for the sake of simulation, if you were to wire normal physical push button, let's say we have a rig or a test station, you wire a normal physical button or a sensor, the signal is coming in physically to the PLC, this will work. But for the sake of simulation, we cannot simulate, you can't force value to a physical address. It won't go. So, but we can make use of a memory. So we can use M. So even this memory, we can just give it, instead of writing it here, let's do this. Instead of just giving it random. So let's go to our tag table. Come under here, say start. Start 2 and stop 2. So instead of this being an output, so what the tag table does is it automatically continue the addressing for you. But since we're not using it as an output, we're using it as an input. So we want to use it as a memory. So we just come here, rename it M. You can use the 4.1 even directly. So just put your M here, then okay. So it's now memory byte 4, bit 1. So for this other one also, change it to M. So what do we have? Memory byte 4, bit 2. So let's come back here. So you now press start 2. So we already have memory there. Look at, instead of going to your PLC address table for memories only, you can do M4.3. What happened? It automatically generates the memory for you, but it will not name it. You have to go to, either you go to your tag table or you right click the way I did and then rename it. You cannot say this is stop. So because there are times where you are programming and then you need a tag and you did not define it on your tag table before, you can generate it here for memories. So you can, Donald Trump, please let my screen be. So then we have stop. So I think we're good like this. So who remember the last thing I said we'll do after we have a block here? If someone can remind us in the chat. Said we'll do something before simulating. You use to force value into super Caleb. That makes sense. That means you are with us. You force value into an input and it work, or what did my engineer said? Can we use the simulator and force the value from there? Michael, if you are talking about an input, like you force value to an input through simulation, I would like to learn how, so I can also do the same thing. So for engineer Caleb already said what we need to do. Just call it in OB1. So just drag it here. What do? You've called it in what? OB1 already. So that's it. Then do you make use of first table or you modify value to 1? What do you do, Michael? So you've called it here the testing block. So now we can just run our simulation, compile. So I just want us to see how the set reset work. See, loading, there's an error. OB1 mean testing block that is assigned. Okay. We are here to compile our testing block before we compile the OB1. So let's go and compile our testing block first. We've compiled it successfully. Now we can now go back to compile OB1. No error. Successful. So start simulation. Super. And still loading. So I want to show us how the set and reset operation actually works. So start search. This simulation would only work if you have your simulation PLC sim for that version downloaded on your computer. If you don't have it downloaded, it will not work. So someone does not feel like I have the PLC TIA portal, my simulation is not working. So then you load, consider as trusted. Load. Then finish. So we can now go online. Network is a little bit bad. That's why it seems like I'm lagging. So we are online. I did call this guy in one now. Okay. No problem. No problem. So we call it in one. Then download again. How did I know there's a problem with OB1? You see, this is not green. So if you want to know there's no issue with your program after going online, everything the status has to be green. So look at what happened now after I download in OB1. So everything becomes green. So I know we are good to go. So we go to the block we want to use for testing. Then we monitor our block. So since we're monitoring it already, let's now modify this to 1. So look at what happened when we modify it to 1. The set operation starts. So look at what happened when I remove the signal, modify back to 0. This is still active. The output here is still active. I think, because some people might think it's just showing green. Let me use that output to energize something for us. I'm coming. So we can all see that the output is still active. That is not just let me say pump. Let's use Q 4.1. So let's go back here. So now that we've made changes, you say this is Q motor and this is pump. Let's want us to see the operation of the set and reset. So let's download back to our PS. So look at this. After we've removed it, even after we've off the input signal coming from the memory, the motor is still on. So see it here. The motor is still sending signal to the pump. So look at what we do now when we reset it. This is the reset pass. When we send signal to the reset. Let's look at what happens. So modify to 1. So it goes off. Immediately you modify it to 1. You can even turn this off back now. Once you modify it to 1, it goes off. So this is also the same thing as if you even latch it. So let's do latching here. So we all see something. So instead of creating another magic, just bring this in here. Bring this in. I want to use latching in place of set reset. So we see they are both doing the same operation, but one makes the program simpler and make it more effective than the other. So that's why I used to tell people that we can have different program structure and achieve the same thing. What you're writing in 4 different DB, different FC, someone might come and just use maybe one block, one move block or one command, and then you'll be surprised that you're doing booting. The same thing. So it's not about how much space you take or how long your program is. It's about how effective, how readable that your program is. Can operator or someone that is not there when you're writing the program pick up your program and read it and work with it effectively? If not, then you failed in writing a program. Because if you are writing a program and it is not readable, then I don't think it is worth it. So now let's use latching operation here. So we can use this. Let's bring this here. Enter. To start it, instead of using the set, so it does not go ahead to set it. Let's use normal output coil. We'll call it motor. Let's use it here also. Okay, motor is here already. Then look at what happens now. Let's download. So the same thing that a latch command will, okay, hold on. Sorry. I'm here to latch it. So the output of the the person that was asking about what is latching. So this is what latching is basically. The output here, you bring it here just to retain contact. What that set and reset just did for us now. That's what we're trying to do. So enter and then bring it here. So download. So let's start it now. Modify. So let's take away the signal. So we've turned off, let's say this is a push button. We've pressed start and we've moved our hand from the push button. So now the motor is still on and we're not using set. Look at it down here. The motor is powering the pump and we're not using set or reset. So what do we do now? If you want to stop it, see the stop command here. That's what latching is basically, just to retain the contact. Then you come here, you press the stop push button. So you press stop now, modify to 1. What happened? It goes off. So it's just like you are still pressing reset. So you are still pressing the stop here to reset it. Then it goes off. So that is it basically. For the engineer that was asking about positioning of our start and stop, let's do something around that. Sorry, are we all clear with this now? Or do anybody need me to go over it again? Please, let's talk in the chat box if we still have somebody that need clarification on the set reset operation. So we can know we are moving forward. If we are good, we can let me just get some reaction. We all know we are good with the set reset. What happens when set and reset are both true at the same? What do you say? Yes, I use the simulation to. Okay, I get what you did. Please, what are we trying to achieve with the program you're writing? So we're trying to make use of the logics that we learn in the what is this thing called on the slide. So there are some different instructions for PLC. We have set, reset. So what does set? You set old signal even after the push button or whatever is sending the signal and stop sending the signal. That's what we just displayed now. So we have set and we have reset. So what the set do with the name implies set, it set it hold the signal. What does reset do? Once reset receives signal, it resets it from holding the signal. So for the engineer that was asking about what happened when set and reset are both true on the same scan. So nothing will happen. Let me just show you. So if set comes before, because if set comes before reset, how will I put it? It depends. Someone already answered here because that was a beautiful and it depends on which is dominant. Yes. So if set comes before reset, then it will be set. But if set comes after reset, then it will not come on. But if both of them comes on simultaneously, or let's do an example because it's better seeing it than we just talking. So let's do a beautiful example about that. So let's do an example on this. Mr. Gbenga, do you want to say something? I don't know. I think it was a mistake or something. So for the person that asked about the set reset, so let's do something. Start 2. Bring this here. Put this up here. Then move this. Just turn this to set. So once it's set, it's reset. So look at this now. Let's download and simulate. Load. So look at what happened when let me modify this to 0 first. So look at this. This is 1 already. So it's already set. Then let's bring the reset command also. Look at what happened. Let's see what happened to the output. Oh, I've moved the output here. Okay, this is the output. Look at what happened to the output. I want us to see here. Look at what happened to the output. See, because reset is on, the output is off already. The output is not coming on. But let's do it this other way. Because of what this engineer was talking about. Let's modify this to 0. Modify this to 0. So let's turn on this first. And turn on this second. And see for ourselves. So what happened? It's still 0. So as far as the reset is powered, if set and reset is pressed, there will not be any output. The power will not come on. So I think we're good now. The person that asked that question. So the set reset, Emmanuel Edosa also, I think you understand what the set reset does. Clement, I think we're good. So I don't understand the latching you just did now. It seems you use to latch at once. Even me, I don't understand your question. Can you just restructure the question and type again? Okay, I don't think this person is still active with us. So let's move to the next one. So the next one we're trying to learn is, let me check from the slide. Let's do the comparator. I think we can use the comparators now. So we already understand how the addressing work, how the set and reset work also. So now let's go to the comparators. So for the comparators, let's create a DB. So this is how to create a DB, a data block. Come here, create a data block. Then click on OK. Okay. The normally close, yeah. Okay, Collins. I'm sorry, I forgot. So the other thing we're doing, okay. So for the normally close zone, Let me delete this here. Let me bring it up. This is normally. So let's bring normally closed down here. So we should put normally closed before normally open. Let's name this one stop. Stop 2. And this is start 2. So like I said before, okay. Let's just do it this way. The only way it will not work is for latching. Even the latching. There's a way we should be able to do the latching. Hold on. I like it when we challenge ourselves this way. So we get to see. Okay. So we've put it first like this, right? So let's change this one to normally the normal coil. So let's download. I think time is fast spent already. So I think this is on because the motor is on. Let's stop this first. Modify this to 0. Then use the stop. Modify this to 0. Modify this to 1. So it has gone off. So let's modify this to 0 back. So now the start push button is what? Is after the stop. So are you with me, this person, Collins? So what do we do? Let's press the start push button now. Modify the start push button to 1. So it comes on. Then the latching, let's modify it to 0. It remains on. The latching is working. So the same thing that happened when we did that. So now if you press the stop push button, you put the stop push button at 0, at 1 now. That means you are energizing it. It will go off. So it's the same operation, the same thing as arranging it that way. The same thing as arranging it this way. I think you get it now, Collins. If you have any question, please, let's state it now so we can move on. I think Collins get what we are talking about now. So no matter your position, you just need to know how you arrange your coil to suit what you need. It's just your arrangement that matter. Okay, thank you. So now I said we'll create a data block for this one we're trying to do, the comparator. So for the data block, let's have two functions. Let's say age, and let's say year. Or age and number. So data type, bool. I said bool accept 0 and 1, but we're doing comparison. Comparison is between two values, not not through trigger bits, not through normally on and off. It's not like when this is on and off. So we're doing it through to integer. So you have to change it to what? Integer. Change this also to integer. You can compare integer, you can compare real value, but you can't compare bool. So we've changed this to integers. Let me property. So after changing it to integer, now let's go to let's compile the block. So after changing it to integer, we can compile our block now. Then go to inside this block. So you can come to your instructions to look for your move. But I have a, should I call it simpler way of doing my move? You can come here, just bring a block. Look at where I drag my block from, bring it here. Type here, move. Is it move or comparator we're using? Not move or I'm sorry, there was a network breach the other time. So I think we're all on the same page. Let me know if this was the last page we saw before everything went off. Sorry, please, can I get reaction if this was the last page, if we know how I got to this part? If not, let me just go back and take it again. Okay, yes. No, no. Okay. Let's go back. So what I did was, I said we'll create a data block. Okay. So what I did was this, I said we'll create a data block. Like I said before, a data block is like a bank where you store different data. So for this data block, the data we're storing inside us are what? Integers. This is why it's short of integer, that's why they put int. So I create a data of what? Int, age and not number. Then after creating, what type of data block? This is a global data block. Just come here, add the add block. Under that, you see a data block, just create normal, that's all. Nothing serious, no catch. Then we'll go to our FC back. I did what did I do? Bring this. Then I said instead of going to instruction to look for your move command, to look for your comparator command. So hold on, we'll get there, please. To look for your comparator command, you can just drag this down, put it here, then come here and click on. You can put your greater than sign there. See it. Just bring it less than. Then you click on it, enter. That's the other thing I've been doing since. Then I'll now say, okay, you just click on this data block. Then check under here. All your data in the data block would come up here. So you want to check if age, the one up or age is comparing the one up to the one down, is less than number, then the motto should come on. So what is happening in this operation now is, even after you press your start button, the PLC will come and check, is age less than number? If age is not less than number, even after you press your start button, the motto will not come on. But if after you press your start button and the PLC comes here and check, age is less than number, it says, okay, then it does what? It starts. So let's do a very quick example so we can all see what I'm talking about. I think we're all together. So Look at this now. Age and number is what? 0, 0. Let's press our start push button. Let's modify this to 0. Then let's press our start push button, modify to 1. We press our start push button. See, it's not going. The motor is not coming. Why? Because age and number is what? They are equal. Age is not less than number. So let's modify age. Let's split our screen. Close this part so it'll be bigger. Let's go to age. Right click on age. Modify upper end. What do we want to put in age? Let's put 1. But let's make age 2. See, age value have changed here now to 2. So age is still what? Age is still greater than, what's this thing called? Age is still greater than number. So the motor will not come on. So what do? Let's make number 5. So now, if number is 5 and age is 2, that means age is what? Less than number. The motor is supposed to come on. Let's try that now. So what happened? The comparator have compared. They checked that, okay, age is 2, and then our number is what? 5. After comparing both integer, it discovered that, okay, the operation has taken place, then the motor will come on. So what happened if during the operation, age now become higher, or it become higher? What happened? It cut it off immediately. With immediate effect. So I think we get what is going on here now. Please, if we are together, let me get reactions. Let me just know we are still active together. So it does not seem I'm just doing magic here. So if anybody has any question or you don't get what I just did. So I'm trying to show how the comparator work. We'll still make use of another comparator. So we can make use of greater than or equals to. Then the move command before we call it a day tonight. I'll make sure we make use of move at least. So there's no question, right? If anybody have any question, you don't get how I use it. So I'm trying to paint a scenario. Let me see what scenario I can paint to. Okay. There's one thing we call backwash on sound filter. There's one thing we call backwash on sound filters in industry. A sound filter is just like a tank that has different sizes of stone and sand inside used to purify water before it goes in for production. They have different processes from sound filter, active carbon filter, and all of that before it gets to the storage tank, before they use it in the factory. So there's something we call backwash in it's a sound filter. So in a sound filter, for backwash to take place, what we used to check for, we check for the pressure of the inlet. There are different methods. We can use flow, we can use pressure. So we now check for the pressure of the inlet and the outlet. So a sound filter has an inlet part where the water comes in from. Then the water goes through the sand bed and all of that. Output of the tank, we have an outlet there. So what we do is we put a pressure transmitter at the inlet point of the sound filter and another pressure transmitter at the outlet point of the sound filter. So we check the pressure, the real-time pressure difference between both of them. We now look at it, okay. So I'm trying to, for someone that say we don't understand how the comparator, how we use the comparator. So we put a pressure transmitter at the inlet point and put another one at the outlet point. So what happens is you write a command like this, the comparator that is checking. If the outlets, normally for normal operation, if there is no blockage, calm down. I should calm down. Why? So for normal operation, if there is no blockage and the sound filter is okay, that the sound is not old or something, the outlet is supposed to be greater than the inlet because the water coming from the inlet will take time, pass through sand, pass through granite, other different sand of different shape and sizes before it gets to the outlet. But anything that make the outlet the outlet pressure lower than the inlet pressure. That the outlet pressure is lower than the inlet pressure, that means the backwash needs to take place. So to write that program, what will we do? We'll come here. The way I created a data block, we'll create a data block. We'll bring a comparator. So for that person, see how to use your comparator. Bring a comparator. So let's say this is the inlet. This is inlet pressure. Let's say we're monitoring pressure now. And this is outlet pressure. So let's now say, let's use another one. Let's use greater than or equals to. So now say if inlet, so once inlet is greater than or equals to the outlet pressure, once inlet pressure is greater than or equals to the outlet pressure, then let's say this output now should not be motor again, should be what? Let's change the name to backwash. Now this is just a typical example of how control work in the factory or breweries. That's how you see it. So let's change this to backwash. So what is happening here now is once you press your start push button, the PLC will check, is the inlet pressure greater than or equals to the outlet pressure? If yes, then start backwash. So now let's download and then do a practical example. Time is fast spent, so I want us to do at least use that move also before we call it a night. So let's change this. Look, why is it going now? The start button is pressed. This is 0 and this is 0, which is what? Equals to. It's not greater than, but it's equals to it. So once it's equals to it, the backwash is what? Active. The backwash will take place. But now, let's take this back to 0. Modify this to what? 1. So it will go off. Now let's go to our data block. So let's make the outlet, modify outlet to be 7. So modify this guy back to 0. So let's press the start push button again to 1. So look at what's happening now. What was our condition for it to start? The condition is if it is not greater than, the condition is if it is not greater than or equals to 0, if it is not greater than, if inlet pressure is not greater than or equals to outlet pressure, the backwash should not start. So what do you notice here? The inlet pressure is 0, which is less than 7, and it's not even equals to 7, so the operation will not take place. But if I now increase the inlet pressure, inlet pressure to 13, look at what happened. Because the inlet pressure is now greater than the outlet pressure, you know the pressure will be accumulating and the pressure will be changing with time on the tank. Once you connect it to the tank, it will not be stagnant, it will not be a one-time thing. So we can just put it here, then the backwash take place. So for Michael Samuel, I think are you the one that asked it? Do you get how we use it now? Michael Samuel. Say, please, where do you get the offset? So I want to do something. Hold on, please. I'll show you how I got the offset now. Property, optimize block. Okay. So when I wanted to get the offset, you just come down here. Properties. If you want to use offset, optimize block. Click OK. You off, switch it off. At the pressure sensor analog input, then you click it, then the offset will show. Then you compile your block. So the pressure sensors will be analog signal. And then for analog signal, you will not wire them because the signal that you'll be getting from the pressure sensor are not 0 and 1, are not like start and stop or like the one you'll be getting from your normal regular sensors. So what you'll be getting from them will be in form of analog signal. So you'll be wiring them in to an analog card, AI card. That's why we have digital card and analog card. So if you are wiring them to an AI card, they have different wiring diagram. You follow the wiring diagram and the addressing will be input word. So you are not more using bits, you are not using bytes. So you are using what? Word. So for word is what? 16 bits. 16 bits make one word. So that's what you are using input word 2 or input word 4. Let me show you an example here. This is an example of our word. Let me close this guy. Let's go to the property. So look at it. Let's say I have a pressure transmitter now. I can just come here and say inlet. Hold on. So let's say I have a pressure transmitter. I will not say inlet pressure. Inlet pressure. I don't want to start typing it up. Then you can put the outlet. So whatever value you are getting here, you're not using it directly. You have to convert it to an engineering value using the scaling block that someone talked about. We'll not be able to use scaling block tonight, but in some other lecture, I think I'll be able to show us there are different scaling block. There is an inbuilt one. So I want us to use the move command. So this is it. You have scale. Let me see first. See, look at it. High limit, low limit, return value, the out. So you can put the in, all of that. This is a scaling block, but we'll take that in another class. The code has not been sent. The code will be sent soon. So let's just do the move. Then after the move, we'll send the code and answer questions and everybody can now rest. So we don't just start learning, taking too much stuff. So move. Let's use move. Move. So for move command, even for comparator, you cannot move from a large address. Let's say you're moving from bit. You can't move from bit to word. You have to move with the same address range, with the same bandwidth. So let's say you're moving from integer, you'll be moving into another integer address. And moving from word, you'll be moving to another word. I think you get what I'm saying. So you're moving from here, you're moving to another, the same address, but you can't move bit. It's not like you say you want to go and start moving A M0.0. So let's do a typical example here. Let's go to our DB. So, or let's just use this guys here. Let's delete this. Move, open your DB here. Move inlet. Let's move inlet to outlet. So, let's see what will happen. So what this does is that whenever the start button is pressed, this does not concern it. The backwash will come up, but along the line, as far as the start button is pressed, it will move any value that is in the inlet, move it to the outlet. So let's go online. So after this, so after this, we can take questions, and I hope we are learning something here. Because our final project for this PLC class will be very, very simple. So let's go to, let's monitor, then split our screen. So what's in inlet is 0, outlet is 0. Let's make inlet 2. Look at what will happen to outlet now. If inlet is 2, outlet becomes 2. So what the move operation does is anything you put in inlet, it moves it to outlet. But it does not do that in reverse manner. So let's say this guy is 3, it will not take it. Because what is expecting is that anything that is in inlet, that should be in outlet. You cannot be putting value from outlet to inlet. So let's change this inlet to 3. Modify up prime 3. Let's even change to 33. Look at our output also become what? 33. So it's as simple as that. As far as they are both the same data type, which is integer and integer. So from here our next class, we'll start taking real industrial problems. Problems like, okay, you have to start 4 motors, you have an integer. Can you perform the move? No, it won't work. Let's do it. You'll see what will happen. I always love when you ask questions like that and I'm able to just show you instead of just saying it with math. See, so to check what's the problem, look at what you go to your syntax, trying to pull this up. Look at network 1, data type bool is not permitted here. The upper end require an input or output missing as an incorrect data. So you see what happened? It won't even allow you to proceed. So the data type that you're putting here, bool, is not permitted. So I think that answers your question, Mr. Elijah. So that being said, and that being done, I never even check on our YouTube family. So from our people on YouTube, let me see. I think the last time, I think our YouTube people are chilling. They are no, you are not forgotten on YouTube. We are all together in this. So for someone is asking question, can you perform this? Okay, no, you can't perform it. So attendance will be dropped. I'll drop the attendance soon. Let me see. So while I'm trying to generate the attendance, if you have any question, please just kindly type it in the chat box so we can address that. And once people start taking the attendance, everybody can go and sleep. We'll call it a night and see you in our next class. If you have a question, kindly drop it. Let's have it. Let's have it. So I think the code is ready. Sorry for disturbing. My offset is not appearing. So why would it not appear is because you have not compiled your block. After you've done the optimize, you off the optimized data block, then compile, it will appear. I want to seek for something. I don't know if it is possible. As far as it's not money, it is super possible. It's only money that I cannot seek for. So the code is ready. Shit. Made me forget again. Okay, Q9B. Yeah, hold on, please. Let me just drop the code first. Q9. So that's the code. Our YouTube. Person, someone is already dropping code before we drop it too. So that's the code. I just drop it on YouTube also for our YouTube family. So can't you see the code I pasted now on YouTube? It's in the chat box. So for the person that says you, multiple on large run on latch. I don't think I get your question, Pelumi. Said, is it a bad practice to have multiple on large runs on for the exact same bit? I don't think if I get what you're saying correctly, it's like you're having multiple input signal and you're not latching any of it. I don't think it is bad. As far as your signals are coming in the correct order. So for the person on Zoom, please, can you raise your hand? You said I should unmute you. Just raise your hand, please. Okay, Collins. So please unmute and then let's have it.
Yeah, good evening.
Yeah, good evening, engineer.
I really appreciate the class that you've been on with us. So, but I just want to draw your attention back to that plan of 18, not even this one in particular.
Okay.
So that's why I said I want to seek for something. I don't know if it will be possible.
So what do you need in E-plan?
Now, the last this thing about the panel, how can the panel design?
Okay.
I went through the video, but I was lost. So I don't know if I can message you personal, like I can drop a message to you privately on WhatsApp so that we can get that back.
Dropping a message is not the issue. The problem right now is I'm quite occupied, but what we can do, nevertheless, is to create a time where myself and you would work things out. But for now, my Saturday and Sunday has been booked. So what me and you can do is on Friday. Okay, tomorrow is Friday.
Tomorrow is Friday. Yeah.
Tomorrow is Friday. Around 8:30 in the morning tomorrow. That will be before I start anything in the office. So
8:30 is bad for me because I'm going to work tomorrow. So by that 8:30, I'm going to be like I'll be very, very busy by that time.
because I'm also going to work. Why I'm saying 8:30 is before I'll leave the office for site because I will be visiting supervising some job tomorrow. So that's why I'm looking at 8:30. But if that won't work, then we would have to move it to maybe at night on Friday. I won't be chanced. I won't lie. And Saturday, what do you say?
I said it won't be a chance tomorrow night.
Yes, I have something I want to work on tomorrow night. So what we can do is send your questions down this night. If I cannot answer it this night, first thing when I'm free tomorrow, I would answer it. Then you go through it when you are free also. Then you send your response. When I'm free, I answer. So I think that will work for us.
No problem.
Yeah, beautiful. So thank you very much. Yes.
Thank you so much.
Yeah, no problem. Cool.
Okay.
So which other person? I think I saw another hand up. Kenneth, Mr. Kenneth. I had a lecturer with that name. Mr. Kenneth, please, you can come up. You can have.
Okay.
Yeah, good evening, Mr. Kenneth. I can hear you.
Good evening.
Yeah, good evening, Mr. Kenneth.
Yeah, please. My question is this move and the jump design that we had just now. Which
Okay.
system can we apply these designs in industry?
Yes, you can apply it in any system. I made a reference to an industrial setting of a sound filter. I don't know which industry do you work in, or where are you familiarized with? Are you familiarized with Nigerian Brewery, Nigerian Bottling Company, or where? Engineer
Yeah, like
Kenneth, I'm
Nigeria
asking.
Brewery.
Okay, if you are working in Nigeria
Hello?
Brewery, I don't know if you, yeah, I'm with you. If you are working in Nigeria Brewery, I don't know if you've heard of the sound filters. They have sound filter, carbon filter, raw water tank, all of that in the is it utility area. Have you heard of any of that?
Hello?
Engineer. Hello, I said, have
No,
you heard of any
network
of
wahala.
that?
Hello, can you hear
Uh,
me?
yeah, I can hear you. I said, if you've heard of, have you heard of water treatment plants like where you have the sound filter, the carbon
The
filter,
voice is
the raw
breaking up.
water tank?
I don't know if you can come again.
Eh?
The voice
Okay,
is breaking.
yeah, let me say it. I said, you said you work in Nigerian breweries. So I said, have you heard of sound filters in the water treatment, like a place where they call water treatment plants?
Yes, sir.
You've heard of it. So in the water treatment plant, they have a tank they call sound filter. So I'm trying to place example where we can use that move and the jump.
Okay.
So on the sound filter, we will have what we call backwash. The backwash is like washing the tank whenever the sand, because with the name sound filter, they use sand to filter water to remove dirt from it. So they use pressure transmitter. For the engineer, they will call us in, then we take pressure transmitter, we install one pressure transmitter at the inlet part of the sound filter, another one at the outlet part of the sound filter. So for their backwash operation to take place, the PLC, we bring in PLC and other stuff. So for our program, we write a program that the PLC should compare the input pressure from the pressure transmitter, compare it with the output pressure. If the input pressure is greater than the output pressure, then trigger a backwash. So that's where we can use
Okay.
that comparator. You can use it to compare, okay, input pressure, output pressure, trigger backwash. You can use it also in the filler or labeler. Okay, let's say from the filler now, you are counting how many bottles is coming out. You are using a counter and then a sensor there. How many bottles is coming out? Then how many bottles is the filler calculating that is filling? You are counting the 12, then I say, okay, if this is not equals to this, trigger an alarm to show that maybe one bottle is broken inside the filler or something has stopped the filler that is just wasting drink. Because let's say it has 32 nozzle and it's filling and capping with CO2 and all of that. So after filling and it's coming out and your counter is counting it, we have FBI and all of that, but I'm just playing a scenario. And your counter is counting it, is noticing that it's 25 bottle that is coming out and filler is supposed to fill 26 bottle at every interval. Then you can use a comparator in your program to count it. Instead of using hand to count it or use eyes, you may not even be there. You just use comparator in your program that, okay, compare what 26 to what the filler is giving us at the output. If it is not the same, if it's not equal, use the equals to. If it is not equal, trigger an alarm. Then the alarm will blow. So the operator can go and check that, okay, why is this alarm on? You now see it that, okay, this is what is causing the alarm.
Okay.
I don't think you get what I said.
Yeah, I get you.
Yes, yes. So those are the applications. Before the end, maybe on Saturday, we would start taking real industrial questions. It's because of time. I had some question in mind today, but I don't think we can work with them.
Uh,
Yeah. So by Saturday, we would leave the introduction. We'll start taking real industrial question, building some complex program. So who have any other question, please, before everybody go and rest for tonight? Samuel David, I think we're good. It has been a while I haven't heard from you. You have disturbed me, sir, my attendance. I saw one.
I'm good though.
Okay, thank God, engineer.
But okay. I have a challenge though on my tap water, so I don't know. I've not been
That's some
practicing
issue.
because of my tap water. It's giving me one or two issues.
Is it that your license is not active,
I'm
or
still
what's the
finding
problem?
the license is active, but when I go to try to pick my CPU, it just keep loading. It just
That
keep
means your
loading,
license is
loading,
not active.
loading till
If you want to be
eternity.
sure your
It's not
if you want
opening
to
for
be sure
me.
your license is active, if you want to be sure your license is active, go to Windows, search for Automation License Manager, open
Yeah,
it.
yeah.
Then under your Automation License Manager, check for the version of TIA you are using, if the license is there.
I'll
Yeah, if
still
it's
check.
not there, that means you have to delete it and then reinstall to get your license. There's someone I'm
Right.
looking for on this live. I think she have run away. Is Sophia with us? No, she's not with us. I think we're all done with attendance also, and we don't have any other question, right? Please, let's confirm that. We don't have any other question. Okay, Musa Indris has a question.
All right,
I know
thank
why.
you. Thank you. Can you hear me, please?
Yes, I can hear you loud and clear.
Okay, so mine is on all this greater than equal. It's like it's a bit confusing to me. Is it that let's say for example we are using equal? Is it that when it's not equal, like to raise alarm, or when it is equal? And like it's
Okay, if you are
confusing
using
me.
equals to, let me explain it. Comparison is comparing between two things. Like you see that I did in that play, I put one up, I put another thing down. So what is
Yeah.
happening is it's comparing the one up and the one down. If you put equals to, it will check that is the one up equals to the one down. If it is not
Okay.
equals to, the output will not come on.
Okay. Okay. Okay.
It's not like
Okay.
it will
But
trigger
when
an alarm. If you want it to trigger an alarm, that means you connect it to an alarm. You can connect the output to an alarm.
Okay, that means when it is not equal to, that is when it will come on, or when it is equal.
So if you use equals to, then when it is equal, that means that's when it should come on. If you use less than, that means when the up one is less than the down one, that's when the output should come on. But if you use greater
Oh,
than, what will happen is when the up one is greater than the down one, that's when the output
okay.
should come on.
Okay. 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 I understand now. Thank you very much.
Yeah, no problem.
Yeah.
So don't worry, the move comparator, I think I'll find a question that is compatible. I will not be available on Saturday, so someone else will take the class. I'll find a place that it is compatible. Maybe during our next class, if I'll be taking it. How do I do to mark my thing? I don't think we should be having this conversation now. Kenneth, maybe is this your first class? So I think we are good. Think we're all good. We're all good. We did not have our Ghanaian brother tonight. Oh, Ekpe Favor, I saw your LinkedIn post. So I must say, well done. Well done. After Isaiah, let everybody go and sleep. Oh. We'll see tomorrow. Yeah, thank you. So
All
Isaiah,
right.
please, let's have a quick one.
Okay, no problem. Thank you.
Yeah.
So, for this data block
Okay.
inlet, so you made mention of data block inlet, the addressing and outlet. So you made mention the comparison, the whole scenario that you were talking about. Now I
Yes.
want to know because now for this data block, you need signals to perform the operation, right?
Yeah.
You
So
need
I said you
signals to
should
perform the
visualize. Yeah, I said you should visualize the data block like a bank. So what the data block does is just to store your data. You just keep your data inside. So is anything you put inside data block that will be there? You understand? I don't know if you can still hear me.
Okay, something caught me. Can you come again, please?
Yeah, I said you should visualize the data block like a bank. Is anything you put inside the data block, that's what will be there.
Okay. So what I'm trying to say is, how do you feed in input? How do you give the data block? Because you're talking about binary here. Maybe you're just giving it.
Okay, number. So giving it input, that's where your HMI
that's the
comes in.
input. Maybe
Yes, I get
analog
your point.
signal from
That's where your
a pressure
HMI.
transmitter or
Yes.
a
Your pressure
transmitter or
transmitter.
whatever instrument on the field. So now, how do you address these inputs to this data block? Like, okay, it's collecting these values from somewhere. It's not just
Yes.
generating it from wherever. So
Yes.
how do you say, okay, you're collecting, this is where the data is coming from? Like now
Okay.
we have the like now we have the stats that is, for me now, the stat is
A push button from
like
outside
0
is
bit
coming.
0,
0,
and that
yes.
input is coming from the address by 0 bit 0. That's what's
Yes.
going to trigger the start. And you also have the stop signal, which is coming from by 0 bit 1, which is going to trigger
Okay.
the stop. So I'm just using that as a scenario. So I want to understand, how do you address just like that now? That ones and zero, they are a piece of information that carry out the instruction
Yes.
based on the conditions. I want to know, how do you input signals to this data block? Because it needs data like ones and
Yes, I
zeros
understand.
to
So
operate. I don't
yes,
know.
I get your point. So
Thank you.
that's where move come in sometimes. Oh, for your what is this thing called? Like analog signal now. Let's use a very good example. Let's use an encoder that, let's say an encoder is placed at the end of a motor to measure the position of the motor, how fast it's running, and all of that. So the encoder will be giving you your feedback, like your results back in analog form. You use a scaling block to convert it to a real value or an integer. What do you now do? Once you've converted you'll be able to wire your encoder directly to an analog card. The input you're getting from the analog card, you scale it to a real value. After scaling it to a real value, you now use move.
Move.
You
Okay.
use move. You now move it from where it's coming from the analog port to the data block. You understand? So if you are moving it to
Okay.
the data block, the one that is in the data block is now what you now be using. Let's say you want to use it to compare, you now pick it from the data. So the data block is getting the data, the zone data now directly from a physical device because you have used move to move the data from the physical device to that data block. Also, you can use an HMI. There are some places where you want your operator to be able to give set points or to set how many something is coming or that. You just connect it to an HMI. You know what an HMI is, Engineer Isaac?
Yes.
Isaiah.
Human
Ehen.
machine interface. Yeah.
Yes. So an HMI now, the person will just type it, put the number in. If the person is putting the number in, you are not connecting wire physically to it. You just link the data block. We'll still treat HMI before the end of this thing. You link the data block to the HMI screen. So what happens is whenever the person is putting the data, is storing the data, the number or anything the person is putting in to the data block. So from the data block, you can now use it to write your program inside the program. You understand what I
Oh,
said?
yeah. Okay.
Yes.
So what you're trying, in essence, you're saying, okay, should in case, let's just say you're monitoring temperature and you don't want the temperature to come below set point, you can use that comparator and
Yes.
use the move to
Yes.
connect
Yes. Yes. Yes.
that data. After you've
Yes.
scaled it, after you've
Yes.
scaled it, you use move to
To move it
now
to data
channel it
block.
Yes, into the data block. Okay.
Yes.
But I don't think you've treated that today.
No, we've not done that. That's something. So we're just still familiarizing ourselves with the command. So it will not seem strange when we start picking it and saying, okay, move
Okay.
this and that. Yes.
Okay.
Yeah, no problem.
Oh,
Let's hear from
okay.
Dave
Thank
and
you.
call it.
All right.
You're welcome. So Dave, please, that will be the last question.
Good evening.
Good evening.
Can you hear me?
Yes.
Okay, so concerning the e-plan, the 3D parts too, I'm also having some difficulties, like in terms of um knowing how to size the panel and those parts. So I'm just like still saying because of the other guy too made mention of it. Maybe if maybe like can organize something, maybe like a class or a time for us to just run through it.
Okay, I think what we'll do is we'll drop a poll on the group maybe tomorrow or next tomorrow. How many people are still having issue with e-plan? Then we can now talk to the organizer to generate a class for us. I can't do that on myself.
Okay, thank you very much.
Yeah. So concerning this person talking about, I didn't mark attendance for the first 2 days. I don't think that is in my hand. So you can go to the Ask for Help group, type it there, and tag Miss Adebite. She would be able to attend to that. So people on YouTube, let me confirm there's no question from anybody on YouTube, and we can call it a day. Yeah, I have no. Can we have breakdown of this class? Okay, I think we're good. No question from YouTube also. So thank you all for attending tonight's lecture and have a beautiful night rest. Thank you. Good night.